Today we're going to talk about how we can convert a quadratic in standard form to a quadratic equation in graphing form using the method called completing the square. A couple things to note before we get started. The quadratic in graphing form goes y equals a times the quantity x minus h squared plus k, where hk represents the vertex of the quadratic and a represents the stretch value of the quadratic. So to get started, we will look at a quadratic with an a value of 1. In order to use this completing the square method, the first thing we're going to do is set up our square. Similar to factoring, we'll begin by putting the x squared term inside of our box. Now, we need to take our x values and split them up equally into our box to create two equal dimensions, because we are trying to create a square and squares have equal side lengths. So we will take our 8x, split it up into two equal parts, which will give us 4x and 4x, which will then allow the dimensions of our box to be x plus 4 times x plus 4. We know these are the dimensions since x times x gives us x squared, x times 4 each gives us the 4x. We also know this creates a square because the two sides of our box have equal side lengths. Now, we do have this missing side, or this missing inside to our square, which we can get by multiplying 4 times 4, giving us 16. Now, if we look at this square, we can think of it in terms as algebra tiles. So in order to complete this square, we have used one x squared tile, 8x tiles, but we did use 16 individual tiles. However, if we look at our original equation in standard form, we only have 11 individual tiles to work with. So in order to keep our equation balanced, we have to subtract off 5 individual tiles. So we get 16 minus 5, giving us the 11 from our original problem. Now that we have completed the square, we have also balanced out our equation so that we weren't using any less tiles than what we were given. We can write out our equation. So the dimensions of our square give us x plus 4 times x plus 4, and then we have that minus 5 on the very end. Because we can shorten up x plus 4 times x plus 4, we can rewrite this as x plus 4 squared minus 5. And since it is an equation, we don't want to forget that y equals out in front. There we have the quadratic y equals x squared plus 8x plus 11, rewritten in graphing form as y equals the quantity x plus 4 squared minus 5. For our next example, we will be looking at a quadratic that has an a value that does not equal 1. For this example, the first step we must take is to factor out the a value from the very first two terms of our quadratic. So we can rewrite this equation as y equals 3 times the quantity x squared minus 6x plus 31. We can use the same steps before to complete our square using the x squared and negative 6x tiles. So first we will draw our box, place the x squared tile inside of our box, split up the 6x tiles into two equal parts, which gives us negative 3x and negative 3x. Find the dimensions of our square, which is x minus 3 and x minus 3, and then fill in the last little part of our square, which we can get by multiplying negative 3 times negative 3 to give us positive 9. So we've now completed the square with the given x squared minus 6x tiles. However, because we factored out this 3, we know that we have 3 of those squares, which means instead of having only 9 individual tiles, we actually have 27 of them, because 3 times 9 is going to give us that 27. So now we have to ask ourselves, we used 27 tiles in completing the square, but our original problem states that we have 31 tiles to work with. So how do we get from 27 to 31? Well, we have to add 4 additional tiles to our square in order to complete it, to fulfill our standard form of the quadratic. So in order to write this out, we have y equals 3, because we have 3 of our squares. We can write the square as x minus 3 squared, since our square is x minus 3 times x minus 3. And then we have our plus 4 on the end of that square. So that is how we can convert the standard form of the equation to the graphing form of the equation. A couple things to note with this final form. We have our a, h, and k values, so we can also identify this vertex to be 3, 4. And we can also identify our stretch value using the a value as 3. And this can help us easily graph or locate the parabola for the quadratic on a coordinate grid.